All right, students, finally, we're going to look at section 11.8. This starts on page 840, multiplying and dividing radical expressions. Obviously, I'm running through these a little bit more quickly than you might, but just make sure you read the information off to the side and pause the video. Take your time, make sure all the steps make sense. So, example 1, part A, we're looking at the square root of 3 times the square root of 6. Well, let's think of that as the square root of 18. Following that, let's think of the square root of 18 as the square root of 9 times the square root of 2. And the reason is because the square root of 9 can be broken down. The square root of 9 is just 3. So the final answer simplified is 3 root 2. Secondly, 5 root 3, all in parentheses, squared. That means 5 root 3 times 5 root 3. You're going to multiply the parts that are red together, the 5 times 5, and get 25. Square root of 3 times square root of 3, well, that's square root of 9. Square root of 9 is just 3. And finally, if you take 25 times 3, you get 75. All right, part C, the last one. You want to multiply everything under the square roots together. So you take the square root of 8x times the square root of 4x, you'll get the square root of 32x squared. If you take the square root of 32x squared and break it down into the square root of 16 times 2 times x squared, look at how the colors change. The square root of 16 becomes a 4. The square root of 2 stays the same. The square root of x squared becomes x. And you can take 2 times 4 times x out front, 8x, and keep the square root of 2 after it. Let's move on to the top of page 841, example 2. So here you've got, take a look, the square root of 2 and then parentheses 5 plus root 12. We are going to have to distribute as the book says. So you can see the distributing that happens. We get the square root of 2 times 5 plus the square root of 2 times the square root of 12. Well, the square root of 2 times 5, you can see it's 5 root 2 for 5 steps in a row. That you can't do anything with that. Now the square root of 2 times the square root of 12 is going to be the square root of 24. The square root of 24 breaks down to the square root of 4 times 6, and the square root of 4 itself simplifies to 2. So you're having the square root of 24 turn into the square root of 4 times the square root of 6, and eventually you get 2 root 6. That's simplified. 5 root 2 plus 2 root 6 is simplified. You cannot add those together because one has the square root of 2 and the other has the square root of 6. You can't add things together that are unlike radicals. And now a distributing problem with subtraction. Similar subtracting steps as we had last time. You get to the point where you get the square root of 9 minus the square root of 15. The square root of 9 is just 3. That should be automatic to get that. The square root of 15 doesn't simplify anymore, so we keep the answer as 3 minus root 15. Example 3 at the bottom is not something I'm going to go over with you at this time. If you wish, you can take a look at it and try a couple problems besides these couple to see if you get them, but that's going to be for a high school level math class where those problems would be of concern to you. Finally, example 4, we're on page 842, division. So if I take the square root of 2 divided by, the square root of 7 divided by the square root of 2, we don't want a radical in the denominator. So we're going to do something called rationalizing the denominator. That's the title of this example. This will be really important in geometry. It's not that important right now in algebra, but in geometry you will definitely need to know this. So if you take the square root of 7 divided by the square root of 2 and multiply by what is in red, which is the square root of 2 over the square root of 2, that's going to help us get rid of the radical in the denominator. It says, the explanation says to multiply by a form of 1. We're always allowed to multiply by 1, and the square root of 2 divided by the square root of 2 is equal to 1, so we're allowed to do that. We then get the square root of 14 divided by the square root of 4, and hey, the square root of 4 is just 2. Your final answer is the square root of 14 divided by 2 because you can't break down the square root of 14 anymore. That's an example of rationalizing the denominator, and what we're doing is getting rid of the radical that's in the denominator. Similar question here in B, it just takes some more steps. We're going to start by changing the bottom
the bottom is the square root of 8n, we can write that as the 2 root 2n. We can then multiply by 1. And this form of 1 that we're multiplying by is root 2n divided by root 2n. Well, guess what? If you take root 2n times root 2n, you get root 4n squared. The square root of 4n squared is 2n. So now you can see if you take a look at all the steps, you would end up getting the square root of 14n on the top, and on the bottom you eventually get 4n once it's all simplified. Take a look at the explanation for each of those steps.